carbon and its compound. Organic compounds. Organic compounds. Hydrocarbons. Types of hydrocarbon. Saturated and unsaturated hydrocarbons. Cyclic hydrocarbons. Organic compounds. The compounds of carbon are known as organic compounds. Some of the common types of organic compounds are hydrocarbon, haloalkanes, alcohols, aldehydes, ketones, carboxylic acids. Hydrocarbons. Hydrocarbons are the simplest of the organic compounds. These are made up from hydrogen and carbon. Most of the hydrocarbons that we use come from natural gas and petroleum. Here we will see hydrocarbons with 1 to 4 carbons. Example, methane, natural gas, propane, butane, etc. The most natural source of hydrocarbons is petroleum. The natural gas which occurs above petroleum deposits also contains hydrocarbons. Types of hydrocarbon. Hydrocarbons are of two types: saturated hydrocarbons, unsaturated hydrocarbons. Saturated hydrocarbons. A hydrocarbon in which the carbon atoms are connected by only single bond is called a saturated hydrocarbon. These are also called alkane. Alkane has only single covalent bond and no double or triple bonds. Methane, ethane, propane and butane are all saturated hydrocarbons which contains only carbon-carbon single bonds. The general formula of an alkane is CnH2n plus 2, where N is the number of carbon atoms in its one molecule. Unsaturated hydrocarbons. A hydrocarbon in which the two carbon atoms are connected by a double bond or a triple bond is called an unsaturated hydrocarbon. Ethane and ethyne are two important unsaturated hydrocarbons. Ethane contains double bond and ethyne contains a triple bond between the two carbon atoms. The unsaturated hydrocarbons are obtained mostly from petroleum by a process cracking. Alkenes. An unsaturated hydrocarbons in which the two carbon atoms are connected by a double bond is called alkene. This double bond is formed by the sharing of two electron pairs. Ethene and propene are the two examples of alkenes. The general formula of an alkene is CnH2n, where N is the number of carbon atoms in its one molecule. Alkynes. An unsaturated hydrocarbon in which the two carbon atoms are connected by a triple bond is called an alkyne. This triple bond is formed by the sharing of three electron pairs. Ethyne or acetylene and propyne are the two examples of alkyne. The general formula of an alkyne is CnH2n-2, where N is the number of carbon atoms in its one molecule. Alkyl groups. The group formed by the removal of one hydrogen atom from an alkane molecule is called an alkyl group. Examples of alkyl group are methyl group and ethyl group. Methyl group is formed by the removal of one H atom from methane, and ethyl group is formed by removal of one H atom from ethane. The general formula is CnH2n plus 1, where N is the number of carbon atoms. Cyclic hydrocarbons. The hydrocarbons that are arranged in the form of a ring are called cyclic hydrocarbons. The cyclic hydrocarbons may be saturated or unsaturated. A saturated cyclic hydrocarbon is cyclohexane. The formula of cyclohexane is C6H12. As we can see, the molecule of cyclohexane has 6 carbon-carbon single bond and 12 carbon-hydrogen single bonds. The saturated cyclic hydrocarbons are called cycloalkanes. We have the cycloalkanes with less than 6 carbon atoms in the ring. The cycloalkane having 3 carbon atoms in the ring is called cyclopropane. The cycloalkane with 4 carbon atoms in the ring is called cyclobutane. An unsaturated cyclic hydrocarbon is benzene. The formula of benzene is C6H6. The structural formula of benzene is as shown. The benzene molecule has 3 carbon double bonds and 3 carbon-carbon single bonds. It also has 6 carbon-hydrogen single bonds. A single bond of benzene consists of 2 shared electrons, whereas a double bond consists of 4 shared electrons between any 2 atoms. The unsaturated cyclic compounds like benzene are called aromatic compounds. Naming of hydrocarbons. The official names of hydrocarbons given by the International Union of Pure and Applied Chemistry are known as IUPAC names. Naming of saturated hydrocarbons. Here are some examples to understand how to name the carbon compounds. Naming of CH4. This compound contains 1 carbon atom, which is indicated by writing as meth. The compound is saturated as it has all single bonds, which is indicated by writing as ane. Therefore, IUPAC name of this compound CH4 is methane. Naming of C3H6. This is the structural formula of C3H6. This hydrocarbon has 3 carbon atoms which are represented by word prop. This carbon is unsaturated as it has 1 single bond and 1 double bond. The double bond is indicated by using the ending ane. Therefore, IUPAC name of this compound C3H6 is propane. Naming of C2H2. This is the structure of C2H2. This hydrocarbon contains 2 carbon atoms which are indicated by writing eth. This hydrocarbon is unsaturated as it has a carbon-carbon triple bond. Therefore, it has an ending ine. The IUPAC name of C2H2 is ethine. The common name of ethine is acetylene. This is a table where indicated that how we can easily access the name of hydrocarbons. Isomers. As we all know, a given molecular formula represents only 1 compound. Example, H2SO4 represents only 1 compound, sulfuric acid. In organic chemistry, hydrocarbons can occur in the form of molecules that are made up of the same number of atoms of each type but have different structures. This phenomenon is termed as isomerism. Consider an organic compound C4H10 having 4 carbon atoms and 10 hydrogen atoms called butane. This is the structural formula of normal butane having straight chain of 4 carbon atoms. Now in this case, number of carbon atoms and hydrogen atoms are the same. But here, 3 carbon atoms form a chain and 4th carbon atom joined in the side chain to form another structure as shown. This is a structural formula of isobutane. In both these cases, the only difference is both normal butane and isobutane have the same molecular formula, but they have different structures. The organic compound having the same molecular formula but different structure are known as isomer. Isomerism is possible only with hydrocarbons having 4 or more carbon atoms. Homologous series. We have seen that carbon atoms can be linked together to form chains of carrying lengths. In addition, hydrogen atom or atoms on these chains can be replaced by any of the functional group like halo, ClBr, alcohol, OH, aldehydes, CHO, ketones, CO, etc. This functional group dictate the properties of the carbon compounds. Example, the chemical properties of CH3OH, C2H5OH, C3H7OH having the OH group are all very similar. Homologous series for alkanes. Methane, CH4, ethane, C2H6, propane, C3H8, butane, C4H10, pentane, C5H12 are first 5 members of the homologous series of alkanes. The general formula for homologous series of alkane is CnH2n plus 2. Homologous series for alkynes. Ethyne, propyne, butane, pentyne, hexyne are the first 5 members of the alkyne homologous series. The general formula is CnH2n minus 2. Characteristics of homologous series. All the members of a homologous series can be represented by the same general formula. Any two adjacent homologous differ by one carbon atom and 2 hydrogen atoms in their molecular formulae. The difference in the molecular masses of any two adjacent homologous is 14U. All the compounds of a homologous series show similar chemical properties. The members of a homologous series show a gradual change in their properties with increase in molecular mass. Summary. The ability of carbon to form chains give rise to a homologous series of compounds in which the same functional group is attached to carbon chains of different lengths. The functional groups such as alcohols, aldehydes, ketones, and carboxylic acids bestow characteristic properties to the carbon compounds that contain them. This is all about this subtopic, students. We will see chemical properties of carbon compounds and some important carbon compounds in our next topic. Keep learning!